as a speaker, we have Professor Pratap Srinam Sundar and Professor Chandan Chaudhary. We will be talking about the various aspects of the biomimicry inspired sustainable practice in the manufacturing, as well as what needs to be done post COVID-19 era to accelerate the digital adoption. So without wasting any more time, I'll hand over the stage to Professor Pratap Sundar, who will get started with it. Professor Pratap, over to you.
Thank you, Avi. Good evening, everyone. And today we have these two topics. One is biomimicry inspired sustainable practices in manufacturing by myself. I am Pratap Sundar, as Avi has introduced. And the second topic, accelerated digital adoption post COVID-19 era by Dr. Chandan. This is the agenda. We have two topics, 30 minutes each, and then the final key takeaways will be presented. Now, let me present my part first. This is the very interesting topic which has fascinated me for the last 25 years or so. And the outline of my brief presentation for 30 minutes is like this. What is biomimicry? And we will see a 3x2 matrix for inspiration and overview of our manufacturing methods versus nature's manufacturing methods and
Professor Pratap, I'd like to just interrupt. I guess we are not able to see your screen. If you can share your presentation with us, that'd be great.
I'm sharing.
I guess we are not able to see, so if you can just quickly close it and reshare. Great.
Are you able to see, Avi?
Yes, sir.
So this is the outline. Avi, are able to see all of you?
So we are in a position to see the screen.
Okay, this is the outline as I explained. And in 1997, I happened to read a book by Janine Gaines, who teaches at the University of Montana. She wrote a book by the same title, Biomimicry Innovation Inspired by Nature. And she is the president of Biomimicry Institute also. And it was the great inspiration for me personally to understand our manufacturing methods versus nature's manufacturing methods. Biomimicry, you can understand in this way, is a practice that learns and mimics the strategies found in nature to solve human design challenges and find hope along the way. The goal is to create products, processes, and policies that solve our greatest design challenges in a sustainable way and in solidarity with all life on Earth. We can use biomimicry not only to learn from nature's wisdom, but also heal ourselves and this planet. We are stressed. Our planet is very much stressed. If you consider the pollution, plastic waste, garbage, all these things, and climate change. Many are losing hope that we will stop at 1.5 degrees or 2 degrees, which may not be really possible. So that is the meaning of biomimicry. And here we can see a 3x2 matrix. When there is a design challenge, there is a design problem, we take this small matrix in which the rows represent 3 M's, model, metric, mentor, and 2 columns represent form and function. So model means when we have a design problem, for example, the solar cell that taps the sun's energy is an inspiration from the leaf. So we look to nature for models to solve our problems. So that is the meaning of the model. Study nature's models, imitate or take inspiration from this design and process to solve human problems. That is the meaning of the word model. When we come to metric, metrics are essential. For example, cost is a metric. Efficiency of a solar cell is a metric. Cost of a solar cell, efficiency of a solar cell lead time to manufacture a solar cell. All these are metrics, and these metrics must be we must be able to develop them according to some ecological standard, such as recyclability, reusability, remanufacturability, and so on. Mentor, in this case, as explained by Janine Beniers, mm, is nature, uh, nature herself. So, not our attitude should be not on what we can extract from nature, but on what we can learn from nature. That is the um, mentorship we have to cultivate in observing nature and learning from nature. Let me give an example. All of you know echolocation. Echolocation is prevalent in nature. Many bats, variety of bats, dolphins, porpoises, they use echolocation to hunt prey, to locate their nest, and all so on. So, a study by United States Air Force long back, they compared the efficiency index of the radars that United States Air Force has manufactured, designed and manufactured versus the efficiency index of the BATS sonar system. You will not believe, but this is a scientific fact. It is based on weight of the system, peak power output, diameter of the target, echolocation efficiency is computed on these three metrics, and a relative figure of merit is arrived at. BAT's echolocation index figure of merit is a trillion times more than the best radars that human beings have designed, scientists have designed. This is one example of that illustrates how nature is superior in both design and manufacturing. One more example, a leaf plays very crucial role in producing food, as all of you know. And this leaf itself is a miraculous thing. More than 10 Nobel Prizes were awarded in the field of photosynthesis for the research conducted. If you look at a mango tree, for example, this is the season. I'm sure all of you must be eating mangoes. So 6 molecules of carbon dioxide, 6 molecules of water is reconfigured into 1 molecule of sugar and 6 molecules of oxygen using light only. So the carbon dioxide and water are raw materials. The conversion process uses renewable energy like light only, and then the outputs are sugars and oxygen, which are essential for animal. So this is the equation. The outputs of animals become the inputs to the plants, and the outputs of the plant world again become inputs. This is a beautiful example of circular economy. So nothing is wasted, and not the sugars amount of sugars that we cannot make our food, as we all know. If you have seen the movie Interstellar, once the Earth runs out of the ability to sustain the plant world, we will not have food because we just do not know how to make our own. We have to be dependent on plants and trees. So the sugars, about 300 billion tons of sugars are produced every year, and about 450 billion tons of oxygen is produced by the. Both are essential for the animal world. Not only these things, many proteins, fats, oils, vitamins, medicines, polysaccharides, wood, cellulose, and so on, which are all essential for animals from cradle to grave, is produced by plants. Manufacturing. Our focus is on manufacturing today, sustainable manufacturing, what we can learn from nature. Is something, if you look at the word manufacturing, it is verb, it's a verb, which means make something, produce, build, construct, assemble, put together, and so on and so on. And if you want to make something, first thing you need is material, and then you need some machines to convert these materials into end products, and you need energy to run all these machines, and you need information to control the whole system, which includes our industry 4.0 and all the modern technology. And what we do currently is take resources from nature, raw materials, for example, make, use, and throw into the nature again. That is called waste. And in making, we use very crude methods like heat, heat. Caustic chemicals are used, and the temperatures are very high in our machines, processing parameters, and treatment that is given to the raw materials, for example, steel sheet, like such as this one, which is used to make the housing for the woman worker. So it is punched on the Yamada punch press. It is made on the Yamada punch press, Japanese punch press. The pressures that are used, the noise that machine produces is very. The after effects of our current manufacturing methods are just high cost. It uses non-renewable resources such as electricity produced by coal, thermal power, the oil, or petrol, diesel, and so on. And our manufacturing is generally very noisy, and it is highly polluting, and it generates a lot of scrap. And recycling is a very big problem, as all of you know, the world is awash with plastics and garbage. One more example I want to give from the manufacturing point. Let's take an object such as an egg from nature. This egg has many parts actually. Our time does not allow us to go into details, but all of you know that egg has outer shell, inner membranes, and egg white, egg yellow, and so on. So if you can nicely write the functional constraints. So this is the input-output model of the egg. Input is a cup of grain, output is an egg. The enabling mechanism is the hen itself. So the conversion process happens inside the ovary, oviduct, the factory. Let's use the terminology, manufacturing terminology. This is the oviduct inside the chicken, which is about 70 centimeters in length, and the lead time for manufacturing one egg is 24 hours. And there are various stages. The details, our time does not allow us to go into details, but I just want to tell you that you have to view this as a factory, nature's factory producing eggs. And this is the value stream map I made by studying it very deeply. Value stream mapping, I am sure many of you have used it. That is a Japanese lean tool to calculate the value addition percentage. This percentage is usually very low in many companies. I visited about 400 companies, and usually it is less than 10% in many companies. So at assembly line is number one with maximum value addition percentage, about 50%. That is the maximum reported in the research literature. But here in the oviduct, the factory inside the chicken, the value addition percentage is almost 100%. You can see the gap between the nature's manufacturing and our manufacturing. Our manufacturing. Number of eggs produced worldwide, you see the graph, it is about 1,200 billion eggs per year. That means about 4 billion eggs per year. Without pollution, without noise, without machines. So if you consider the characteristics of the oviduct factory, it's a long tube. The information is stored in DNA. Tube length is about 70 centimeters. It's a lights out factory, dark inside, and no workers, operators, supervisors, no planners, schedulers, no material suppliers, no tools, no machines, molds, furnaces, no high pressures, no temperatures, high temperatures, caustic chemicals are used, no sound, no noise is produced while manufacturing an egg, and so on. And you can see the beauty of this factory. And can we ever build such a factory to manufacture something like an egg? That is the question I would like to ask all of you to think about. You have to think about deeply. We are nowhere, and you cannot manufacture 4 billion eggs per day without polluting the environment. But nature doesn't pollute at all. 4 billion eggs are produced without any pollution. And egg, over the bill of materials of the egg, if you carefully look at, everything goes back into the nature, reused by the nature. Nature, these are the certain sustainable practices by nature. Nature recycles everything. In nature, waste equals food. There is no waste in nature. Nature is always cradle to cradle, whereas our system, manufacturing systems or supply chains, is cradle to grave. Nature uses local resources and materials that are abundant. For example, if you look at the your own human body, no humanoid robot can come closer to the human body. But human body material cost is only 1,000 rupees. You consider your body, it's about 60 to 70% is water. Nature uses abundant materials that are available. It never uses high cost, rare materials that we use, for example, microprocessors, computers, and so on. So these are all, nature does not create monstrous hybrids like landfills, or there is no confusion of those in nature. Nature respects diversity, which means ecosystems, or industrial ecosystems are there in nature. Um, there are metabolisms in nature, technical and biological. So I will let me give you an example. How people are learning, how many hundreds of startups began no, innovating, and this is one such example. Innovative design. The mission of this company is better way to feed the planet and reduce the amount of plastic used in consumer products. That is the mission. And they have used mycelium foundry. Mycelium means a type of fungus. So they have developed microflux foam. This is a platform. Material is a platform from which you can make different variety of materials for different applications. And then microcomposite is a material that comes from nature's mushrooms, no, root system. So suppose we have wood waste. The wood waste combined with mushroom root system creates a very good foam type of material that can be used for packing products. And you can throw the packing material back into nature. It will become part of nature. Currently, our plastics or thermocol and these things do not become part of nature. This is one such example. In Italy, there is a company called Salvatore Ferragamo. And in Italy, there are every year about 7 lakh tons of orange peel is produced by the beverage factories who make the juices and also the roadside juice shops and so on. So what this company did was they extracted the polymer from the rinds of the oranges, from which the yarn is spun. And once you have yarn, biodegradable yarn, you can make fabric. And from the fabric, you can make the apparels of variety, low-cost apparels to luxury kind of apparels. And it is a patented system now of extracting the polymer from the orange rings. And this is this second example I'm sharing with you about how people are innovating, learning from nature. And let me summarize. And see, there are certain rules for sustainability in manufacturing, design and manufacturing. One is material parsimony. That means you have to minimize the types of materials used in products. If you take a cell phone, how many different types of materials are used in making a cell phone? Not only in the product itself, but also in the manufacturing process. Thousands of materials are used. You have to minimize that, and you have to eliminate all the toxic materials in the product and also in manufacturing processes. Then you have to think value cycles, not value chains. Value chain is linear. Value cycle is circular. So you have to recover and reincarnate materials uh, again to create new value-added products. Then you have to use the renewable resources, which is called power economy. Not your product must use, if it needs energy, it must run on renewable energy like sunlight. If it is a manufacturing process, it must be able to run on sunlight or the wind or the tidal power and so on. Then sustainable platforms, product platforms have to be created. Then function must be given priority over form. These are the 5 sustainable principles for both design and manufacturing. And And I'm sure you understand as engineers that the sustainability starts at the design stage, not just at manufacturing stage. So the key takeaway from my presentation is only one takeaway I'm giving you. The man-made world is horribly designed. When you look at a landfill or a river with a plastic or oceans are full of plastic. 34,000 pieces per square kilometer are floating in the ocean. The man-made world is horribly designed, but copying nature counts. This is the takeaway. Biomimicry design shows that. Thank you very much. Now, our ultimate goal of all design and manufacturing is this. Presently, we are operating in linear economy or recycling economy. But we are not recycling everything. Unless we recycle everything like nature does, we will not be able to achieve circular economy, which is called sustainability. This is the takeaway. And once again, I repeat, the man-made world is horribly designed, but copying nature. Biomimicry design shows that. Thank you very much. Over to Professor Chan.
Thank you, Professor Pratap. So with these concluding to the Professor Pratap sessions, I'd request Professor Chandan to initiate his talk. Professor Chandan, over to you.
Yeah, dear friends, the topic that I'm going to cover is about accelerated digital adoption post COVID-19. In fact, we believe that entire digital adoption process uh, is going to receive a new momentum because of COVID. Because people across industry, academia, and also in the society have actually realized the value of digital technologies and digital platforms. So what I'm planning to do is, first of all, I would share with you some of our findings regarding what's the impact of COVID-19 on the manufacturing ecosystem. So that's the first thing I'm going to do. Then I'll spend a few minutes just to make a point that our supply chain is globally integrated. So when you have problems today in different parts of the world, we get impacted. So I would cite a few specific examples. After that, we'll get into the topic, some of my thoughts on accelerating the digital adoption process. And over there, I will try to cover just 2 points. Number one, what's our views on Industry 4.0? Is it going to be relevant post-COVID-19? And if yes, in what form? What could be its utility and benefits? And then we'll introduce a concept called lights out factory. Now, when you say lights out factory, if you look in the literature, you will have a lot of literature. But what I'm going to do is take up a real example from an Indian organization on how do you do an audit to figure out, is an organization a light out factory? If not, what is the gap? So we'll actually take a real example from one of the organizations that we have recently studied. And then finally, we'll sum up the key takeaways. I also wanted to request all of you that please feel free to type out any question that you may have on the topics. So just go to the option Q&A, type out. Please do not type out question on chat. Question, you got to type out on question answer. Now, let me share with you now some of our insights based on a study that we have done very, very recently. So the first slide that you see, it is actually based on 197 responses. And we wanted to understand the people who were a part of our session. What was the percentage of companies whose turnover was below 5 crore, meaning, they're really small companies. So that percentage was 61.9%. In fact, India's biggest problem is our companies are not able to scale up. By the way, there's a study which was carried out long back in 2009 by Asian Development Bank. Now, that study has shown that 84% of India's manufacturers employ less than 50 workers. Now, if you compare this with Philippines, as against 84%, over there it's 70%. If you go to Indonesia, it's 65%. If you go to China, it's 25%. Meaning in China, 75% of the companies are more than 50 employees. Now, our problem is we are not able to scale up. Now let's go to the next part of it, is about our survey that we did, which is recently, with the earlier statistics was from 2009. Now, situation has not really improved, because you find in 82% of the respondents said that they had less than 50 employees. Not only that, 38.9% of the companies were very small. They were really micro, because they had less than 10 employees. Now, if you look at supply chain, if you look at pharma, we are dependent on imported raw material. In fact, 70% of the raw materials come from China. If you look at automotive, the figure is 27% of components come from China. If you look at electronics, it is 43.2%. So in case of pharma, it's 70% raw materials coming from China. And then we have the drug manufacturer converting it into drugs, which we export to Russia, European Union, UK, Africa, and United States. As I mentioned to you, similar is the case, because if you look at China, China accounts for 27% of India's automotive component imports. So our supply chain is dependent on the global supply chain. And if there is a problem somewhere else in the world, we also have problem. Now, during our study, we actually asked organizations, and we had 225 respondents. We asked organizations that if you look at COVID-19, is it impacting your order fulfillment process? The answer was 62.2% of respondents said yes, they have a big problem in fulfilling the promises that they have made to organization. Now, if you look at customer orders, especially when you talk about new customer orders, new sales, because the COVID problem started becoming acute from the month of March, as far as India is concerned. And the 70.5% of the companies say that new customer orders, are having a real challenge. Then we wanted to know from organizations that will COVID-19 have adverse impact on their sales turnover? And the answer was that 76.7% of the companies said that their sales turnover will be adversely impacted. You had 79.5% of the companies stating that their profit is going to have a problem. Now, when you go to cash flow, you have 97.6% of the companies stating that their cash flow is a big problem. Now, if you look at raw material procurement, we had 41.7% of the companies stating that they have a problem with raw material procurement. Now, when it comes to layoff, when it comes to reducing manpower, right? Ground level situation is much worse than what you read in newspaper and in television channels. When we interacted with 209 participants, we had 209 respondents, 59.8% of these respondents stating that they are going to downsize. They are going to ask people to leave their organization. They are going to ask people that they are going to be laid off. Now, the second problem that our manufacturing industry has, especially MSME, is actually productivity. So productivity is a big problem. And an earlier study showed that as far as India is concerned, especially the SMEs, the productivity of SMEs when you compare with China or Vietnam and Philippines, our productivity is just 25 to 65%. So we have a problem with productivity. We wanted to understand that the impact of COVID-19. Now, we had 92.2% of companies stating that productivity in organization has decreased. So you are already at a low productivity. Now it is further adversely impacted. Then we wanted to know that would doing business change post-COVID-19? We had 71.9% of the companies stating that they believe that business post-COVID-19 will go through several changes, right? We asked companies, do you think you need to review your product portfolio? We had 80.7% of the companies stating that yes, they believe that they need to review the product portfolio. Then we actually went to the next question. Do they think that they need to now come out with new products? Maybe the demand for, in many sectors, for antimicrobial product would increase. So we wanted to know, do they think that they need to launch new portfolio of products? You had 70% of the respondents stating they believe that they need to quickly launch new product portfolio. We wanted to know about infrastructure because you have this lockdown, social distancing, working from home, right? So we wanted to know, do they have the kind of infrastructure which is required for working from home? The answer was 54.2% of the respondents said, yes, they have the infrastructure in place. But when you went to the next question, that it's not just using Zoom or WebEx or Microsoft Teams. If our question is, do you have digital innovation platform? platform that you can use for remotely sitting from home. Your factory may be in India, your team may be sitting in United States, you may have another factory in South Korea. Do you have the kind of infrastructure you need so that people can do innovation and work remotely? We only had 8.7% of the organizations stating they have digital innovation platform. In fact, you do have few companies in the country which has got such digital platform, but majority of the companies, major bulk of the companies, right, close to 93% of the companies just don't have such platform. Then we wanted to know whether companies think that digital knowledge will become must, especially senior level. And the answer was 95% of respondents said, yes, digital knowledge is going to be a must. We wanted to know about the channel, the sales channel. We wanted to understand e-commerce because majority of the organizations in the manufacturing industry did not have substantial footprint as far as e-commerce platform is concerned. We had 90.3% of the respondents stating they believe e-commerce platform is going to be important. We wanted to know that do they think employees need to reboot their scientific management knowledge? We had 74.1% of the respondents stating it's not enough if we take decisions based on hunches, based on feelings, based on emotions. We got to take decisions which are objective, which are scientific. And scientific thinking is quite different. If we are familiar with scientific thinking involves a running comparison between what you predict will happen next, seeing what actually happens, and adjusting based on what we learn from the difference. But if you look at our various policies, various actions by organizations, state, centers, you find we keep all the time changing because a lot of our decisions are actually not scientific. Scientific decision making, scientific thinking involves skill sets which help us actually to take decisions wherein we are able to accurately predict. Now, friends, we wanted to know as far as MSMEs are concerned, which is a big chunk as far as India is concerned. They make huge contribution to employment, they make huge contribution to export, and we wanted to know, do they think that they need to leverage digital network? And response was that yes, MSMEs need to leverage digital network if they have to scale up and if they have to be competitive. We wanted to know technologies like artificial intelligence, big data, machine learning, should even MSMEs use it? Big organizations, of course, need to use it. Answer was yes. You had 94.3% of the respondents stated that they believe government should build digital infrastructure for MSMEs because they don't have the fund for that. But without such digital platform, digital innovation, our MSMEs will not be competitive. Now, what I'm going to do, the next slide, I'm going to call out Adit Haridas. Adit Haridas is the co-founder of 4.X, and he is a BTech. He did his higher education from Carnegie Mellon University, from Tepper School of Business, and he also got selected for our advanced management program for manufacturing and operations, which is starting on 24th July. So the next slide, there is a case which will be covered by Adit, and then I would take over again, discuss about what we believe are some of the solutions. So Adit, over to you.
Thank you, Professor Chandan. I hope you can hear me loud and clear.
Yes.
So my earlier avatar was a security cybersecurity professional. And when you first enter the cybersecurity professionals, we are taught that we are the brakes in a car, so that we let the car go at the maximum speed. And when you apply a brake, you can control it. So we were doing cybersecurity drills, and people who understand cybersecurity, we call it red team assessment, for large oil and gas installations, for manufacturing companies, as well as for banks, pharma, and all these other verticals. So when we were approached by one of our esteemed customers in the Middle East, who was in the business of natural gas, with whom we already had an existing relationship, an incident was unearthed. We cannot get into details, but it was unearthed. And unfortunately for me, it was on the OT side of things, or the operational technology. As most of you are coming from the manufacturing sector, I'm very new to this, was in the operational technology side. So words like human machine interfaces, or what you see on the board is SCADA, or the manufacturing execution system, MES, or a repository of all history related data, which is called a historian, were very new to us. So as a cybersecurity professional, we only used to look at exit entry points, who entered an asset, which were at that point in time predominantly software for us. But then it slowly, with the advent of all these SCADA, DCS, and PLC, it also came into the operational technology. Who came in at what time? What did he do? What were his credentials? Did he have access to anything which was not supposed to be seen? Did he take something out? These were the system. These were the only checks that we used to do. So suspicious, anomalous behavior, authentication, audit trails, these were some of the things that we used. But we soon found out that when it comes to manufacturing, it's not generally only the asset health or the asset data alone that will help. You also needed to look at something known as a process data. What were the temperature or the pressure parameters at a point in time, 7 months before probably a malicious activity began? At that time, what were the control systems sending out data? So an integration or a marriage that was there had to be done between the process data and the actual IT assets health data. So the only way we found out that we could do was to collect as much data as we can from the field using UPCVA connectors, and then marrying this to IT network infrastructure data. Hence, that was my foray into manufacturing, and the journey is very new for me. I presume that I will learn a lot from this course as well. So the outcome was that today you cannot have idle OT system and IT system. It's time to marry it and make the digitized OT system safe, secure, and reliable. Over to you, sir. Thank you.
Yeah, so thank you, Adit. I think Adit made a very important point. Digital continuity has become very, very important. Uh, Traditionally, you had two different worlds. You had the information technology world, where you had SAP and other applications, and you had the operations technology, where you had a lot of softwares like SCADA, DCS, so on and so forth. But all these worlds now are getting married, because there is an importance of creating digital continuity. Unless we are able to create digital continuity by bringing information from heterogeneous applications to a common platform, and leverage that with sophisticated artificial intelligence, machine learning, analytical softwares to derive insights, we would not become competitive. Now, friends, I move to the next part of my presentation. The question is, the problems are clear. We discussed about problems, and I've also stated that organizations in India, they agree that there are big time problems, and they are anticipating bigger problems as far as post COVID-19 era is concerned. Please remember, right now, I'm not using this mask because I don't have anybody in my room. And it's not a very comfortable thing to do transaction. We are getting into a world which is uh, what we call as contactless world. My technical team, when they came and they wanted to touch my laptop, I'm uncomfortable now. That was not the case earlier. So people don't want to have contact. There is apprehensions, there is fear. COVID-19 is so unknown. We know so little about it. The world has become contactless. The question is, how do we do business in a contactless world? I think Industry 4.0 will be more relevant post COVID-19. Whether you're a small company or you are a big company, if you want to be competitive, it's very important that you leverage digital technologies to enhance your customer centricity. You got to interact with your customer. So this has become very, very important, customer centricity. You need to use technologies like big data, machine learning, and you got to understand and read the pulse of your customers. In fact, we made a recommendation to Government of India that government need to build not just roads and highways. They need to create, they need to invest into digital infrastructure. And this digital infrastructure should be made available. This may be created by government or may be created through private-public partnership. But even the small companies must leverage this. We must know that our economy is influenced by MSMEs. Even the big companies, their performance depends on performance of their MSMEs. And many of them are competitive because they are able to obtain their input material from smaller companies at a price which is very competitive and a reasonable quality. Now, the second thing is, whatever manufacturing facilities you have, is very important that we ensure high level of productivity of these manufacturing facilities. The third thing is, we need to leverage digital technologies for innovation. Now, when I say innovation, it's innovation in our products, innovation in our services, and also innovation in our business models. Now, friends, let's spend a few minutes and discuss the topic called lights out manufacturing. Now, lights out manufacturing is also known as dark factory. Now, in a dark factory, you need no human intervention. It's a factory that runs without any human intervention. And the machines that you have in a dark factory, they run automatically. And you don't need operators. You do not need any surveillance. So, dark factory, there are many organizations now, they are trying to do an assessment. Is my factory a dark factory? Any of you want to need an assessment, do get connected with us. We recently did a study. We wanted to understand various technologies of Industry 4.0. We did this study across many plants, and I'm just trying to show you one organization which has got 11 plants. We wanted to understand whether the plants use advanced robotics. Now, advanced robots are different from traditional robots. We wanted to know, do they use additive manufacturing? We wanted to know, do they use augmented reality? We wanted to know, do they leverage simulation to understand the behavior of product that they have designed or the product that they're going to manufacture? We wanted to understand, do they understand what is horizontal and vertical integration? If yes, are they able to leverage horizontal and vertical integration? Are you able to connect suppliers? Are you able to connect your, what you call your customers? We wanted to understand, are they leveraging industrial Internet of Things? Do they leverage cloud computing? Do they have cyber security? You know, because our manufacturing facilities, organizations are becoming highly connected. So are your plants cyber secure? We wanted to understand, do they use big data and analytics? We wanted to understand, do they use digital twin? You have a factory, but do you have a replica of the factory in the computer? And you can do simulation of various things on your digital twin. Now, when you ask these questions from senior managers and managers, you find many of them said yes. So you see so many yes in so many plants. Then we did a reality check. We asked experts who are familiar with the plant, and we found that the answer was no to all cases. So the problem is, even at a senior management level today, a real understanding of this concept is lacking. The real practical knowledge of what this concept means at an organization level. Now, then we actually did an assessment wherein we looked at 110 sub-processes. So the organization had 110 sub-processes. Now what I did, if a sub-process is manual, we gave, 0 point, actually not 1 point, 0 point. And if it is semi-automated, we gave 5 points. And if it is automated, we gave 10 points. And 110, meaning if everything is automated, then you have maximum 10 points in each cases, which means 110 into 10, if it is a lights out factory, then the total score will be 1100. Now, when you ask senior managers what is their assessment of various technologies and level of automation in different sub-processes, the score varied from 109 to 319. And when you ask the expert familiar with these plans, the answer was 267. So if you look at the gap is lights out factory, a dark factory where you don't need to even switch on the power. Machines can work on their own. The factory can run on their own. It can even 24 hours. Now that factory score got to be 1100, and this organization, the score was 267. So there's a wide gap between the current status versus lights out. But what is also important, that even the senior managers did not know where do they stand, because that's the first step. We need to understand where do we stand in terms of our current level of digital intervention and digital continuity. Now, in fact, I would like to share with you that I believe in future, when companies will buy machines, they are going to ask questions. Procurement will not depend on do you deliver the functionality. Procurement will depend on the machine that you are supplying or the product that you are supplying. Is it a connected product? That's number one. Number two, can you as a supplier remotely take control of the machine? Can you sit in your country, maybe in Switzerland, or you are sitting in Mumbai, where you have your factory where you have manufactured, supplied it to Switzerland. You get connected with the machine remotely and you do the maintenance, you do the optimization, you do the setup, you do the commissioning. Can you do this remotely? So people today, when they buy machines, they are looking at, even as a criteria for selection, how your ability to stay connected with the product. And therefore, many organizations today are talking about building a digital twin. So if I sell my product, let's say I'm selling a vehicle, when my vehicle is on the road, on the physical road, I will retain the replica of the vehicle, the digital version of the vehicle in my organization. And I would have those sensors, intelligent sensors built in the vehicle, which will give me signal, and I will understand the performance of the vehicle so that I can support my customer. I can increase the value that my customer gets. And you have companies in India itself. You have Ashok Leyland implementing this concept of digital twin. Now, I would like to now sum up the key takeaways before we get into question answer. That post COVID-19 era, I think digital continuity across value chain will be a key for survival. And there is a wide gap. There is a wide gap between perception and reality, right? I gave you the example. Light out score was 1100. And senior managers thought where they stand, their perception was their level was much higher than what it is actually. So there is a gap between one is the actual score you need for a lights out factory and your perception and the reality, right? So lights out score is very high, perception is below that, but the actual reality is we are much below that. So there is a wide gap between perception and reality in organizations' lights out score. And I think it's the best time to reboot knowledge and leadership skills. It's going to be very, very important. I think in future, jobs are going to be very risky. It will be very difficult to protect jobs. We got to enhance our knowledge such that our employability is high. And I think ISB's Advanced Management Program for Manufacturing and Operations, which is commencing on 24th July, is a great opportunity for working professionals who want to retain the job, but at the same time enhance the knowledge and then go through these programs. In fact, you will also learn even business schools how they are investing into digital technologies. In fact, the first residency is going to be leveraging ISB's digital platform. And the second residency is going to be in the month of November. So those of you who join the program, you'll actually see the investment that we have made in digital platform to give our students, a good experience and also to give them confidence that we walk that. And I think organizations got to leverage digital technologies if they want to be competitive. So I would like to open the floor for question answer, and please feel free to question. And those of you who already asked the question, I would like to start responding to some of those questions. Let me look at the kind of questions that you all have raised. So there is a question that can you please send the recording to all participants? So that was one request. So we'll send that across, and then you need to ensure that you have registered. If you have registered through the email when you logged in, we'll be sending it to those emails. And you can find me, by the way, also on LinkedIn. Please feel free to get connected. And somebody asked the question, presumably, most of the manufacturing methods, product designs are inspired by nature, including cars, is shaped on animals like sharks for Porsche, fluids on Hyundai, animal bakes. Does it mean we simply need for a realization into embracing nature? Professor Pratap, would you like to take this question? So the question is, do we get inspiration from nature? the participant Sujal Shrestha is telling that Sujal feels that we copy a lot of the design that we see in the nature. So Professor Pratap, would you like to answer?
Yes, Chetan. Yeah, many design ideas came from nature. One of the German companies has designed an automobile outer body based on the fish design. The fish name is boxfish. So these are all, birds inspired aeroplanes, flight mechanisms, gliders, parachutes, and so on. So it is already, from the top for centuries, nature has been inspiring people, engineers, scientists to mimic and imitate her designs, nature. Thank you.
Yeah. So there is a question that, how can we use digital adoption in public health? So I think, in public health, digital adoption is extremely important, right? Uh, and not just currently, now it's pandemic. Obviously, we need to have traceability. We need to understand the spread of the virus, the spread of the disease. And not only that, I think the treatment that in fact you can the entire value chain in life sciences industry today, if you look at some of the top pharma companies of the world, what they are doing is they use digital technology even for the purpose of uh, drug discovery. So you don't start making drugs in the laboratory. After a drug is a recipe, and what they do is top pharma companies work on virtual drug. They even manufacture drugs virtually. People are also talking about administering a drug on a digital human to understand the impact. And when you find everything is fine, then you make the drug physically. In fact, there's a concept called pharmacovigilance. So in pharmacovigilance, when you actually apply drug, a new drug, you launch it in the market. When people start using it, and you use a drug and you find you're feeling a little uncomfortable, and you may type out on Facebook that you used a new drug, and you're feeling vomiting, and then somebody else says, I also had the same discomfort. So if you're a drug supplier, you got to leverage big data and figure out those problems and do the correction before it spreads like a virus. So I think in public health, right, digital technologies are extremely important, and you can do remote. The expert doctors cannot physically see so many patients. By leveraging digital technologies, right, in a remote village in Julmitalaya, there may be a patient, and an expert doctor may sit in Ames and do the diagnosis and provide the medicine. So I think public health, it is very, very important. And Professor Pratap, you have a question that, can you share the slides of your presentation? By the way, we'll share the entire video recording, so you will be able to get all the copies. Any other question? Any other question that you have? Any other question?
And then one question is there from Sushant Saurabh.
Yeah.
How biomimicry can be used in making roads?
Yeah. Can you take that question?
Yeah. See, Saurabh, this biomimicry, uh, that's the ideas of making better roads are already there. Many technologies have come. One thing you can watch on the YouTube is the concrete that is highly porous. quickly the flood water from the rain quickly goes through that. You don't need to big drainage and control systems. You can see what's that in the on YouTube. And also, I want to tell you the so-called the city design, such as, for example, Los Angeles, where I lived for 5 years, is all wrongly designed. The complete concrete beds over the city, the soil, it kills the soil completely degrades. You need something porous concrete, strong enough but porous so that water can seep through, microbes can survive, and so on. You can watch some of this on the YouTube. So, and also roads are against nature. In nature, there are no roads. Road is required only when the automobile came, I mean, wheel mechanism. So, in nature, there are no roads. Road is man's invention because of the wheels invention. So future transport systems will be completely different, which may not require as much roads as we have, so, such as drones and flight, flying automobiles. So thank you very much for your interest. You can watch some of this on the YouTube.
Correct. So I just wanted to, there was a question on the uh, somebody wanted to. I think somebody was interested in cyclical economy. I wanted you to know that those of you who will be joining the advanced manufacturing, advanced management program for manufacturing and operations, we actually take sessions which are on cyclical economy. There was one participant from Dibrugarh, I think is Dr. There is somebody from Dibrugarh who shared his email ID, and yes, obviously we'll be sharing Dr. Pranjul Kumar. So he's a supply chain management expert. So Dr. Pranjul, I wanted to tell you that I was born in a place very close to Dibrugarh, in a place called Tinsukia. So we'll share the video recording with you. In fact, we'll share it with everybody. We answered Sushant's question. We answered the question on public health. We said why it is important. There is an interesting question, and I think it's a very good question. How jobs will be different post COVID-19 era? Now, you saw the survey we did with industry. In fact, people have started realizing the skills which are available today. I don't think it's good enough to be globally competitive post COVID-19. I think knowledge on digital, when I say knowledge on digital, not just knowledge of doing transaction on ERP, knowledge on digital innovation technologies. And if you're a manager, at least understanding of how technologies can be leveraged. And I think jobs in future are going to be very, very different. We are right now doing a research project which is on India's readiness for Industry 4. What's going to be the impact of Industry 4.0 on employment? What are the kind of new jobs and new roles which will be emerging? In fact, those of you who will be joining the course will be joining the findings, and for others, watch out for our publication. So we are left with few more minutes, 2 more minutes in case anybody has question. Me and Professor Pratap, we are happy to answer. So if you do not have any more question, then I conclude. And thank you very much for joining this session. And I hope many of you will be joining our advanced management program for manufacturing and operations. It is a state-of-the-art course. It was conceived along with MIT Boston, and it is run by our Global Manufacturing Institute, which is set up with MIT as an associate partner. And I look forward to interacting with many of you at the campus and also on digital platforms starting from 24th July. Thank you very much.
Thank you.